Hello, this is Robert Guderian, and today we are talking about Numpy. This is round two. Last time we saw one-dimensional arrays where we had an array of data, which felt a lot like lists, except there was some nice extra functions, and we found out that it is incredibly fast. This week, we're moving into multi-dimensional arrays, and that means that instead of just having a strip of data, which you can imagine as a line, we're going to have more than one dimension of data. So 2 dimensions, 3 dimensions, 4 dimensions, and these do map to our real world pretty well. And the reason we do this is for data representation. We are solving problems, and not all problems can be solved with a single strip of data. So what does this look like? What do these feel like to us? Why do we need them? Well, we need to abstract the data into some kind of way we can put it into a computer. We have points. We have 2 dimensions on a spreadsheet. So you can imagine Excel where you have a sheet. There's a bunch of rows, which are numbered, a bunch of columns, which are lettered. Okay, that is 2 dimensions. You can go down a row, you can go across the columns, and you can move around, and you could hypothetically even draw some kind of map of a room on that. Cool, great. But there's also tabs. You can have more than one sheet. That is a 3rd dimension. And then if you were doing some kind of floor plan, you could have sheet 1 as the main floor, sheet 2 is the 2nd floor, sheet 3 is the 3rd floor. Well, that you are describing 3-dimensional space. But you have to imagine it like that. So this is all about how do we look at our data and think, how can we map this into our computer? And generally, we won't actually do floor plans in Excel, but it is totally possible. So we could represent almost anything in n-dimensional space. And this is where it gets very abstract. And this is when you have to think about your data set and think about how you are representing it inside of your computer. Imagine a world where there's a list of students. Okay, well, all of the students that would at one point be in front of me, but is currently my laptop, all of you have a list of assignments. And then within that, you will have a list of questions on the assignment. And then what's the data point we're actually storing? Well, we might be storing the grades. So you can imagine an array where each entry is a student. Then each student, arrows down and commas. I'll only do a few. How many students do we have in this class? About 120, 130? I have 5 students in this example. We'll have a list of assignments. A1, A2, A3. And this one also has a list of assignments. And now I'm regretting already having 5 students. Okay. I'm just going to say ... Okay, we can see that this is 2-dimensional. We have an across dimension and a down dimension. Okay, so you can buy that this is now 2-dimensional data. But there's a list of questions for each assignment. So that means that each one of these, and I will just take student 1 here, or student 0, because we index at 0. This is also a list, where in part 1, you got 10 marks. In part 2, you got 10 marks. This person got 8 and 9. Each one of these is hypothetically a 2-part assignment. And then this one also has 10 and 10. 2, did poorly. And 1, just to finish off. 3 and 10. Doesn't really matter what I write there. This is just an example. But you can see that we would have to index a whole bunch of times to get down to our data point. And our data points are just the scores. So this can be read as the score on A1 for student 1. How do we put this into a computer, though? Well, this clearly will not fit inside of our single list. That's not going to work. We could have many lists. We could have student 1, and then they have a list, and then student 2, S2, and they have a list. But even inside of here, you'd have a list of assignments. And then those have questions, and then that's where our grades are. So what we're seeing here is certainly lists of lists. Different example is a list of stores, a list of days, a list of items sold on that day. And even those are broken into receipts. That is a list of a list of a list of a list. So these happen all the time. But how do we do it for us? Let's start with 2 dimensions, because that can work in our puny human brains very easily. We are used to seeing 2-dimensional space. You are seeing me in 2-dimensional space. This is the top corner of your computer screen. There's the other one. There's the other one. There's the other one. There is a 2-dimensional space in front of you, which I am currently consuming. Hello. So how would we represent this in Python? So let's do it in pure Python first, and then we'll move it into Numpy. Well, clearly I have a list, and we're going to move into a list of lists. This is actually pretty ugly inside of pure Python, and that's okay. And it's something we could hypothetically do, and it's actually not a bad thing to see. I actually don't want NumPy right now, but I will leave it there. Data is equal to a list, and inside of this list, I could just initialize a list. 1, 2, 3, 4, 5, 6. Oh, inside of square brackets because it's a list, and clearly we need 42 and 9001 and 9002. I just have to make it 3 by 3. I can't. That is not a requirement, but it is for me right now. Print data, just because that's how my brain works. So I can hit play, and it prints out, and it is tiny. I can make that a little bit bigger, and it's ugly. Ick. This right here, that's not pretty, but you can see it's clearly a list of lists. How would we index individual items? Well, we have to actually use double subscripting. It's actually my next slide, but we can get to it right here. Where, say that I want just the middle element. So that is this 5 right here. Well, how do we index this? Ooh, interesting. So if we had a list of lists, I would draw it like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is my first level list is this one. I want to get the middle item. These are still indexed the way we'd expect. So if I wanted to get just this row, I would say, if I had a name, I'm going to name it D. I could say D sub 1. Well, when I get this data, it's going to be a list. Okay. Now I want the middle element of that one. Well, guess what? Those are indexed too. It's a list. It's indexed at 0. So I can say list sub 1. And will that work for me? Let's find out. Just the middle element or data, whatever you want to call it. Print data 1, 1. Hit play. 5, which is exactly what I wanted. That is my middle element here. Well, what if I wanted to print this in a pretty way? Well, that's pretty much what the slide that I had just shown was. We could append in data, but we could also use these 2 for loops to print out all our data. If you think back to our printing squares and triangles and stuff with for loops, you probably thought, this is dumb. I don't like this. This is the same problem. 100% the same problem. Except now we have real data, and it's something that we have to work with. If you think about our for loops, our first for loop, our outer for loop, is going to go down this one, is going to go down our rows, because that's how we represent our data. Our inner for loop is going to go over the columns for each row. And you even heard me say 4 in there, right? That is something that's valuable and important. Okay, I think we can do this. I think we can do this in short order. And for the sake, I'm going to iterate two different ways, and these are actually slides that are in here, and you can copy and paste them out. But I will do it live. First of all, I'm going to do it by index. Print the data by index. This is very valuable, even though the syntax in Python is a little nasty. So we're going to say, in theory, we don't know what size our 2D array is. So let's even make this a function. Let's abstract that out completely so that we can say we are past a 2D array of some size, and we don't care what. 2D, and we're going to print it out. Print out the data by index. So again, some shape, and shape is something that we're going to talk about quite a bit, of data is coming in. So there is some number of rows, and that is our outer for loop. And then each one of those is some number of columns. And they need not all be the same length. Ick. And there's more of these, and eventually it ends. Abstractly, this is what we're seeing. There's just 2 dimensions, and that's all we know. And even because it's Python, we can print out anything we want. It doesn't even need to be numbers inside, which is kind of fantastic. So for, I'm going to call it I. I can't tell it myself. In range of the length of 2D. What is this going to give me? Well, I'm going to make this not a 3x3, so it's actually distinct. That we know which one we're looking at. I need more numbers. What are funny numbers? Oh, 10,000, or 1,000, 10,000, and 100,000. Those aren't funny numbers. I just couldn't think of anything better. Well, if we look at our mental model, and we always go back to our mental model, the number of rows is how many lists we have. Each row, each element inside of this list, and we can just imagine this as a list. If we ask for the length of, this is data, length of D, that is going to be the number of rows. Legitimately, how many entries do I have in this outside list? We don't even really have to care that what it's holding is lists. We're just asking for the length of a list, and that list is holding lists. We don't know that for now. We don't care. So this will be 4. Because I have 4 lists in my demo. And I can prove that to myself. Always, if you can prove it to yourself, do, right? I encourage you to run your code as many times as possible. One of the perks of being a programmer is that if you're testing this right now, no bridge is going to collapse and kill people. It'll just crash. And you'll cry, maybe, a little bit. But if you test your code enough, it'll work. Why are you printing none? Oh, I printed printer data. I don't need to print this. The function printer is returning none, and it's telling me it's returning none. Worth testing these. Okay, so I said that this would go up to 4, 0, 1, 2, 3, up to and not including 4, correct? It still ran 4 times, just indexed at 0. So this is doing exactly what I think. Now I can say, instead of saying just print I can say print my data, or it's named 2D here, at spot I. So it's going to give me the index of I. What is that index spot I? It's going to be a list. And it's going to print out my lists in order. And that's already looking a lot more like what we have up here, where it's kind of pretty, right? Good. We're getting closer. Now, I want to... I'm going to use some string... I want to do so much cool stuff. We could use... print formatting on each number to actually space it out. But I'm just going to print them out one by one first. Now I want to iterate down each one of these lists. How many elements do I have in this list? I don't know. I'll have to think about it. Looking back at our mental model, I'm asking myself how many elements are in this list. So I want the length of this array at spot something. I'm going to say 0 for my question I'm asking myself here. I want the length of this list. I'd ask for length of this data at spot 1. Because this is a list, and we're asking for the length of those inner lists. And this will work. Let's make sure it works, of course, because this is confusing code. I'm not going to lie to you. For j in range of the length, or maximum number, is going to be 2d of I. So I'm asking for list I. How long is that list? Well, then I'm going to iterate over that, and then I'm going to print out 2d, and I want to index each one individually. So I will be iterating over how? I'm going to go back to this example. Well, it's going to be over the 0th row first, and then it'll be 1, 2, 3. The inner for loop is done. It's going to go to the second row, 1, 2, 3. It's going to go to the third row, 1, 2, 3. So we'll be going across the rows every time. Now, how do I get the index of each one? Well, this is at 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. Well, there's a pattern there. We have, this is I is going to start at 0. And then this will go 0, 1, 2. 0, 1, then this will go to I is equal to 1. 0, 1, 2. I is equal to 2. 0, 1, 2. So this is, at spot, ij. If I run this, what this should do is print out I, which is the number of this row. Then I'll print out the entire row. Then it's going to print out my contents of the row, 1 per line. And that's what it did. But that's ugly. This is super ugly. I have lots of debugging lines in here. I don't like this at all. It's icky. So I'm going to get rid of this. And now it'll just be the contents running down. That doesn't look like a array to me at all. So what I'll need to do is that stupid Python, we all know that I'm a big fan of this. Give it a nothing line ending, so that'll all go on one line. And now it goes off one line, and that doesn't make any sense. So that means I need to say print nothing to space it out. Now they're better. Now I'm going to change it to use some string formatting, because that's who I am. And I'm going to say that this is an integer. And what's my biggest number here? It is 6 digits long, so I'm going to say it's 7. 7d. So it's going to give me 7 spaces. And we'll write a line on 7 spaces. This is like week 3 material. Dot format. This number into there. And it prints as a pretty matrix. If you don't remember the print formatting stuff, check it out. It's always nice to do. And now this legitimately looks like a matrix, and you can see how I pulled it apart. But if you look at this code now, like step back 2 weeks and look at this, it's almost unreadable. You do get used to the double for loop syntax, but it's still kind of icky. There's got to be a better way. Well, can we iterate over it? So we've seen this for, if we have a list, the data, sure, is equal to, well, these are lists. These aren't even NumPy arrays. I'm going to call it D2. 1, 2, 3, 4. Great. What we've usually done is say for item in D2. So, and then we can say print item, doesn't really matter. And we know that this will iterate through and print each item one at a time, and that's what it does. We can use that same feature. So using the same conceptual model for row in my data of 2D, now row is a single array, or it's made. This is a list. I'm going to call it array. Yeah. Neat. Now I can use that old syntax that we were used to, so we just do it again. For data in row, we can print the data. And this will print it down 1 per line, because that's what it does, especially if we call this function. There you go. I can use this same fancy printy stuff in here. I'm going, instead of printing out the spot by index, now I've iterated over everything and I can just say data. And it does the same thing. Try doing those on your own. It feels terrible the first time. It feels less terrible the second time. By the 10 millionth time, it's second nature. And it's a very common thing for us to do, moving over a piece of data this way. Now, using Numpy, because this is a Numpy week, not just a, iterating over a 2D array week, we know that we can turn a list into a Numpy array in one command, just saying np.array, and then pass it a list of data, D2. Now I have NumPy data. You can see it just popped up in my variable explorer, and it's a NumPy array. Well, we can do that for 2D arrays too. So all I have to do is cast this into an array and save it and then run it. It's going to do the exact same thing. If I just print out data now, it'll actually print out in a nicer way, arguably. But what we've seen here is that NumPy supports iteration exactly like lists, and you can use them interchangeably almost all the time. Now the question is, and this is an important point, why would I want to do this format by index versus using iteration where I just do like this is pretty, right? This is some nice Python stuff. Well, the problem is in iterator, I can't change that data. That is view only. I mean, NumPy would let me change this variable, but it would do nothing. So I can say data is equal to data times 100. Doesn't really matter. It's not going to do anything. If I have my 2D array, I'm passing this by reference. So if I just printed out my data here, it's still the same thing. If I do this up here, is equal to blah. This is already some spoilers into our next class. I'm assigning this spot at spot ij, which is every spot in turn, and multiplying it, whatever data was there, by 2, and then setting it back. That will actually change my data. You can see the second time it prints, it is twice as large. 246 instead of 123. We can actually do assignments if we do this syntax. We cannot assign to an iterator. That does not work. So keep that in mind. If you actually want to change things and you're using for loops, you have to use this icky syntax. Sorry. Python just forces us to do that. NumPy can save us. And we will see that once we do some slicing in 2 dimensions, which is definitely on the docket. I've seen it. I did this code for you. It's available for you. Now, what if we just wanted an array of nothing? Well, we've seen zeros. We could also provide a shape. So I have 2 sets of smooth brackets. What the heck does that mean? Well, this inside brackets, if you look carefully, that's a tuple. So I'm saying give me a shape of a 2 by 2 matrix. And then it'll give me a 2 by 2 instead of just a one-dimensional array. That is called a shape. We're going to see this all over the place. And if we wanted to recreate what I had in the slide here, where I appended in a bunch of data, we could start with all zeros and then use this assigning syntax from my code, which you just saw, and assign in all the numbers, which is neat. And you've seen this. This is here for you. Yeah, so let's actually try this. Let's actually assign the numbers 1 to 4 by using a 2D array. We are going to reuse all of the code that we have already written. This double for loop, I'm legitimately going to copy that whole function because it's important to me. So this will not be 4 anymore. And I'm not going to print it because I don't care. And what I want to do is, this is going to be fill with increment, with numbers. Cool. This will return. I could actually make it. Nah, I'm gonna pass it in. I'm gonna do it by reference because that's fancy. So down here, I'm going to make myself some new data. I can use this np.zeros. And that will give me a shape of 2 by 2. And there's a trailing comma, which I don't really need. Fun fact, tuples just don't care. And I'm going to pass that into my fill with numbers. And data. This is by reference. And then I can print data here. So at this point, I'm going to be multiplying them all zeros by 2, which math I can do is still 0. And we'll print out a 2 by 2 zeros matrix. But now I want to add actual numbers. So current is equal to 1. And then I'm going to assign current here. I'm going to say current is equal to 1 more. And that will assign 1 to the first spot, loop, 2 to the second spot, loop, 3 to the third spot, loop, etc., etc., etc. And I'll fill it. It's actually not too bad. It's kind of pretty. But there's got to be a better way. Oh, I've already seen this too. I jumped totally off my schedule. So we can't actually see this. This is awesome for visual learners, where I can print out a scatter plot of these. There's X and Y's values here, right? That's something we're going to do a lot in this week, where we're going to say this first column is all X's and the second column is all Y's. So 2 and 4 are Y values, 1 and 3 are our X values. So I even named this data. If I wanted to print this, I can actually see it. And that comes up in my plots tab here. 1 and 2, 3 and 4. That's kind of neat. This is some fancy slicing we're going to see. I'm going to be doing some other examples where we can move things around. This is just an introduction to that. We can pass it a list, that's fine. And sum of elements, I'm going to actually leave this as a challenge to you. If we jump over to here, modify this to, instead of filling with numbers, getting a sum of all the elements of the numbers. I'll do that as a demo for you later this week. There is some code golf here. Code golf is writing a program in the minimum number of characters, which is actually pretty fun. But this is where I wanted to go. There is an alternative creation. Instead of saying np.zeros and having these 2 for loops, we can manually tweak every single piece of data. So this is using ND array, where that means n-dimensional arrays. We first pass it a shape. You can see I'm passing it a 2 by 2. I can assign a data type, which I'm saying int64. Remember that Numpy does not support infinite length integers. It only supports 64-bit integers, meaning that there is a maximum integer size, and if we exceed it, that's bad. And a buffer. And I don't really like this term. It's a very old school term, but this is the data that we are going to be adding into our 2 by 2 matrix. The length of this data has to be able to fit exactly into this. So 2 times 2 means that we have 4 spots. I am passing it 4 pieces of data. That is very important. So what does this mean? ND array, new n-dimensional array, 2 by 2 with this data type and this data. So kind of neat. This is finicky. I don't advise using this, but it's here for you if you need something that is exact. Programmers are a bit of control freaks. You're probably feeling that now. If you leave anything to chance, there's a chance that Python will do it differently than you expect. This will do it exactly the way you want every time. So some inspiration, 10 dimensions visualized. This is the slide that you saw. I forgot to refresh. Where this is a really interesting YouTube video that will take you from 1 dimension, a point, to 2 dimensions, 3 dimensions, 4 dimensions, all the way up to 10. And you can actually visualize what 10 dimensions might look like. And this is our real world. Luckily in computer land, we can say what every dimension is, which is very interesting. Summary. This is one of my longer videos. I apologize. Multidimensional arrays are arrays of arrays and potentially of arrays of arrays of arrays ad nauseum. Know what your data set is. What does each dimension mean to you? Most of the stuff we're going to do will map to the actual two-dimensional space because that makes the most sense in our human brains, but it need not be. This is a data representation problem. So thank you for watching. Thank you for paying attention. And there's more coming, and we'll be using these fundamentals. Thank you.